A brute force technique is a technique to solve a particular problem by looking at all possible solutions till we get an answer. There is no proper technique that is involved. Rather, it explores every other solution that it sees, and then after that, it reaches the final solution. It tries to explore every possibility that is involved. So, a brute force algorithm is a simple, comprehensive search strategy that systematically explores every option until an answer is discovered. So, there is a methodical listing. Methodical listing is it will check each and every potential solution in an organized and detailed way, and then it will try to check the right option. The next is relevance. So now brute force algorithm cannot work with a lot of possible options for the solution. So when the issue space is small and it can be easily explored, then brute force technique is a good technique. Let's say if I have to look among two elements or 20 elements, then brute force technique makes sense. But let's say if I have to search for anything in 2000 or 2 lakh elements, then it does not make any sense. So the temporal means time related complexity becomes unfeasible. That is, it's not possible to solve the problem with uh, with those time constraints. Moreover, brute force technique does not use any other kind of optimization or heuristic approaches. Heuristic is something like gut intuition approaches. So it does not take any hint from there. It all just depends on checking every possible option randomly without ruling out anything, depending upon uh, like any other kind of technique. So there are certain features of the brute force algorithm. It's an intuitive, direct, and straightforward technique where I check for all the possible solutions that are there for a problem. Let's say if I have to look for uh, one a particular student in a class, then I can look for the first row sitting, first, second, third, fourth, fifth. Like that, I look for all the girls and I check if I am looking for Rita in the class, then I check if Rita is there one by one. Another way to do, now there can be several ways to do this. Let's say if I know Rita's details, if I know her height order, and then I ask all the girls to stand in the ascending or the descending height order, and then I check that if Rita is, let's say, some 5 feet 6 inches, I will target all the girls who are 5 feet 6 inches. So like this, I'm filtering out all the possible options in case if I take any other way. But then in brute force algorithm, I check each and every solution. If I use some kind of technique, some So here I look for every possible solution that is there. Many of the problems are solved in day to day using the brute force. Like for example, let's say if I have to check for from here the path toward the market, then I'm checking here all the possible paths and then I'm taking the minimum path. Arranging the books in a rack. There again I'm taking all the possible solutions. So daily life activities, we make use of brute force algorithm even though some optimal solutions are also available. Sequential search is one example of brute force algorithm. Under sequential search, let's say if I'm looking for an item in an array, I look for each and every element that is there, and then once I get the element, I return the index of the element, or otherwise I return -1. So I check from 0 to n minus 1. In the array, I iterate over all the elements of the array. If I get the array of the element same as the element that I am looking for, then I return the index, otherwise I return -1. So here I look for each element one by one till I get a solution. Another example of brute force algorithm is exhaustive search. So exhaustive search is a brute force algorithm that enumerates all possible solutions to a problem and checks what is a valid solution. Here it will only involve problems that have a small and a well-defined search space. That is, whatever I'm looking for, whatever are the possible options that I'm looking for, all those are to be clearly specified. So here initially the best solution is null. What is given to me as an input is what is the best set of all solutions, and I should check for the best solution. So initially the best solution is null, that is I do not have the solution, best solution. Then for every element that is there in this candidate solution, I check if it satisfies the problem constraint. I'm checking if it is satisfying the problem constraint. If it satisfies the problem constraint, then I check if I already have a best solution, or is my candidate is better than the best solution. If I get something, a candidate which is better than the best solution, then I change my best solution to this candidate. So, an example can be something like let's say if I am looking for MR grade quality of wood. Now let's say if I have if I have some 5 kinds of wood material available with me. One is teak wood, and another one is engineering wood, and another one is plywood, and then another one is some other grade. So here I first of all check that out of teak wood and engineering wood, I would want to go for teak wood. Now once I get teak wood, then I take the third one, and then there I check, do I want to take teak wood or go for quality number 3, option number 3. Let's say if I still want to continue with teak wood itself, teak wood or quality, or option number 4, teak wood or option number 5. So like this I'm always updating my best solution also. Let's say among teak wood and quality number and option number 4, I choose option number 4. Then I check option number 4 and option number 5. So that is how I am filtering out whatever I don't need, make one as the best solution, and keep comparing that best solution to whatever is incoming. So this is exhaustive search. So here exhaustive search is a